So limiting reactant problems, but a different approach. So showing you how to do it another way. And what's beneficial about this approach is if the question were to ask you an excess reagent question, this approach will help save a little bit of time for how to do that. So stoichiometry, you can interpret quantities for any chemical in a balanced chemical equation. So I can take the 124 grams of aluminum and calculate how much Fe2O3 I need, or how much iron, elemental iron, would be produced. So any chemical can be quantified using an amount given. So just, for example, if you watch the previous limiting reactant play posit, we determined that aluminum is the limiting reagent. Okay. But another way of doing the problem is if we start with our amount, 124 grams of aluminum, we convert it into moles, as we did previously. So 1 mole of aluminum weighs 26.982 grams. But instead of looking at our product, we can quantify how much of the other reactant we need. Okay. So in this case, Fe2O3. And we use the molar ratios. You have 1 mole of Fe2O3 reacting with 2 moles of aluminum. Try to make that F look a little better. I'm just using the balanced chemical equation. And then we multiply by the molar mass of Fe2O3. 1 mole weighs 159.7 grams. And this calculation tells us how much Fe2O3 is required. Sorry about that. And if I do that math correctly, I get 367 grams, which will go ahead and rounding it to 3 significant figures, of Fe2O3. That's how much is needed for this reaction to run to completion. Okay. Then you ask the question, do you have it? Well, do you have that amount of Fe2O3? If you look back at the problem, it says we have 601 grams of Fe2O3. So yes, 367 grams is less than 601 grams of Fe2O3. Therefore, this just confirms the previous play posit that Fe2O3 is our excess reagent and aluminum is our limiting reagent. So if a question were to ask how much excess reagent is left, you can calculate it by using the following formula. The the excess is equal to the actual amount minus the theoretical amount. AMT being the abbreviation. So the actual amount is from the question. So 601 grams. And then the theoretical amount is what was just calculated, 367 grams. Okay. Remember, theoretical amounts are always calculated using stoichiometry. If we do that math, there should be 234 grams of iron oxide in excess or left over. That's a excess reagent type problem. You could also use this to calculate your limiting reagent as well. It's good to have a couple of methods at your disposal for these types of problems.